everyone, this is Mrs. Snowbeck. Today we are going to do Unit 9, Lesson 7, and we're going to talk about surface area and volume of spheres. And so I want you to take a look at these two spheres. You can see there's some vocab words that look pretty familiar. We talked about a lot of this stuff when we studied circles. And so a sphere also can have a chord, a radius, a diameter, a tangent. Remember, a tangent is a line that touches a circle in exactly one spot. Well, a tangent can also touch a sphere in exactly one spot. Also, a sphere can have poles, like with the Earth, you've heard of the North and South Pole. And so the sphere can have any number of poles, an unlimited number of poles. It's basically the two ends of the diameter, no matter which way the diameter is facing. If they're directly across from each other at the ends of the diameter, they're called poles. And then the last thing I want to point out is this thing called the great circle. The great circle is like the circle around the widest part of the sphere. So if you think about the equator is a good example of a great circle. Now let's think about surface area. Let's say you went to the fabric store, you went to Joann Fabrics, and you got some fabric in your favorite pattern. Maybe they're the wild logo or doggy footprints or something like that. You get some material and you think, I am going to make a cover for my favorite ball. And so you start cutting out circles. And the circles are the same circumference as the sphere. And so if you think about like this circumference around the sphere and cutting out circles of fabric, how many circles of fabric do you think it would take to cover your sphere, your ball? Well, you can slice them up if you need to, right? You can take little slices and glue them together or sew them together. How many circles do you think it would take to cover a sphere? Okay, take a guess. I literally want you to think about it and take a stab at it. Think of a number. How many of these circles will it take to cover this sphere? Like a coating over it. All right, now I'm going to show you a little video. Hopefully you have your number. All right, so here you can see there is an orange that has been peeled. The surface area of the orange would be the peel. And if you take these peels and break them up, it looks to me like they are going to fill 4 circles. So think about the area of a circle. If it takes 4 circles to cover the sphere, can you come up with the formula for surface area of the sphere? So some of you might be thinking, well, surface area is going to be 4 pi r squared, because the area of a circle is pi r squared, and it will take 4 of those circles to cover the entire outside surface of the sphere. A second formula that I want to point out is volume of a sphere. How much will a sphere hold? Well, instead of like showing you why this works, I'm just going to give it to you. It is 4/3 pi r cubed. Notice I raised that to the 3rd power. So we'll talk more about that and how that goes into your calculator when we get to that part. Last thing to point out is I just wanted to remind you that R stands for radius. You can see it in the picture there. It goes halfway across a circle, or it can start in the center of a sphere and go to the edge of the sphere. Let's try number 1. Find the surface area of this sphere. Well, we know from before surface area is 4 pi r squared. You guys, this is really straightforward because the r is 6, so it's 4 pi 6 squared. Practice typing that in. Just make sure that you're typing it in your calculator correctly. You should get approximately 452.4 centimeters squared because it's surface area. I wanted to point out in number 2 that 22 is not the radius. When they draw the entire diameter in, that means the diameter is 22, which means the radius will be 11. So if you wanted to find the surface area of this one, it's going to be 4 pi 11 squared. Go ahead and type that in. And you should get 1,520.5 feet squared. Imagine that you cut a sphere in half. Then you get what's known as a hemisphere. A hemisphere is half of a sphere. We live in the northern hemisphere, or some people call us the western hemisphere, depending on which way you're slicing the earth or the globe. So this says, can you find the surface area of a hemisphere? Well, remember how it takes 4 pieces of cloth, or the orange filled up 4 circles with its peel? What would the formula be, or how many circles would it take to cover a hemisphere? Think about that for a second. How many circles would it take to cover half of a sphere? If you're thinking 2, you're wrong. So it will take 2 to cover the curved part of the sphere, but it's going to take a 3rd circle to cover the bottom. It would take 2 to cover the curved and 1 to cover the bottom. So altogether, it's going to take 3 circles to cover the hemisphere. The formula goes like this. Surface area is 3 pi r squareds. And then think about the volume. It will hold half as much. The formula for a whole sphere is 4/3 pi r cubed. So the volume for a hemisphere, half of 4, is 2/3 pi r cubed. All right, number 3, find the surface area of this hemisphere. Again, if you know the formula, it's 3 pi r squared for surface area, and it looks like our r is 2.8. So surface area equals 3 times pi times 2.8 squared. Just easily type that into your calculator, and you get 73.9 centimeters squared. Now, you know we can't keep it that easy, right? We got to make it a little more complicated. So number 4, find the surface area of a sphere if the circumference of the great circle is 5 pi meters. Okay, key words, surface area, sphere. My formula is going to be 4 pi r squareds. Let's plug in what we know. Do we know the surface area? Nope. Do we know r? No. And so here's what we know. We know circumference. And the formula for circumference is 2 pi r, or diameter times pi. And so if the circumference is 5 pi, take that 5 pi and plug it in for the c. So we have 5 pi equals 2 pi r. And then I would divide by pi. The pi's will cancel. Then you have 5 equals 2r. Divide by 2. And r equals 2.5. Now that you have your radius, now you can take that and plug it into your equation. So surface area of this sphere is going to be 4 pi 2.5 squared. And then you type that in. And in this one, it's 78.5 meters squared. Number 5, find the surface area of a sphere if the area of the great circle is approximately 130 inches squared. Okay, key words, surface area, sphere. Surface area of the sphere is 4 pi r squareds. Do we know the surface area? No. Do we know the radius? No, but this one's a little strange. They're telling us the area of the circle is 130. Isn't pi r squared area of a circle? So if you see the shortcut, they're giving us how big this circle is. It takes 4 of those to cover the sphere. So a shortcut is you could just do 4 times 130. Kind of cool little shortcut. This ends up being 520. So 520 inches squared would be the surface area of this sphere. Now, if you missed that, if you didn't catch that shortcut, what you would have to do is think, okay, area of a circle is pi r squared. Take the 130, plug it in for a. So then you would have 130 equals pi r squared. And then I would divide by pi. Those cancel out and you get 41.38 equals r squared. And then you have to square root. And you get your radius. The radius turns out to be approximately 6.4. And then you would have to take this and plug it in up here. And guess what you're going to get for an answer? you're still going to get about 520, depending on how you round the 6.4. Leave that number in your calculator without rounding and you'll have the best results. Number 6, find the volume of the hemisphere with a radius of 6. Volume hemisphere. So pick the correct formula. This one should be 2/3 pi r cubed. Okay, so the radius is 6, so volume is 2/3 pi 6 cubed. When you type this into your calculator, you're going to need to use the caret button, which looks like an up arrow. So here's how I would type it in. I would go parenthesis 2 divided by 3, close the parenthesis. Then I would hit the pi button, and then I would go 6 raised to the 3rd equals. So this is a button, and this is a button, and that's how I would type it in. So please do practice typing that in. You should get approximately 452.4. This is a volume, so it's going to be meters cubed. Remember your cubic units for volume. Number 7, find the volume of a sphere with a great circle circumference of 18 pi. Volume, sphere. Pick your formula. For a sphere, you should have 4/3 pi r cubed. Do we know the r? No. Can we just substitute 18 pi in for pi r cubed? No. Circumference is 2 pi r. So substitute in the 18 pi for the c. 18 pi equals 2 pi r. Divide by pi. These will cancel. These will cancel. So you get 18 equals 2r. Divide by 2. 9 is your radius. Now you can take your 9 and plug it into your formula. So the volume of this sphere is going to be 4/3 pi 9 cubed. Now remember how you type that in. Parenthesis 4 divided by 3, close the parenthesis, pi 9 raised to the 3rd equals, and you should get approximately 3053.6 centimeters cubed. Remember, it's a volume, so it's cubic units. Number 8, the stone spheres of Costa Rica were made by forming granodiorite boulders into spheres. So somebody must have taken a chisel to some rock and chiseled these into spheres. You can see the picture here. One of the stone spheres has a volume of about 113,097.34 inches cubed. What is the diameter of that stone sphere? Look for keywords, you guys. I see volume, I see sphere. And so that's the formula that I want to choose. Now remember, volume of a sphere is 4/3 pi r cubed. Where does the 113,97.34 go? That is the volume, so it goes in for V. So you go 113,097.34 equals 4/3 pi. Do we know the r? No, we do not. So we just leave it r cubed. Think about solving for r. We have to get everything away from the r. There are many ways to start solving this. What a lot of you might do, what you might be used to, is first multiply by, well, I would multiply by the reciprocal. I would multiply this by 3/4. But for some of you, what you do is you do that in 2 steps. You multiply by 3 and then divide by 4. So you decide. When you multiply by the reciprocal, if you put it in your calculator in parentheses as a 3/4, so parenthesis 3 divided by 4, and then multiply by 113,097.34, it should work just fine. On the right side, the 3's and 4's will cancel if you multiply by the reciprocal. And on the left side, you're going to get approximately 84,823. So 84,823 equals pi r cubed. Your next step would be to divide by pi. These will cancel, and so you'll have r cubed on the right, and you'll have approximately 27,000 on the left. Now, if you have r squared equals something, you take what's called the square root. But if you have r cubed equals something, you have to do what's called the cubed root. And it's different than the square root. So I want you to look on your calculators. If you have a TI-30, okay, a TI-30 X2S, which is what a lot of you have. This is kind of the basic calculator that you've had for many years. The way that you're going to type this in, it's above the caret button, okay? So you're going to type in 3 second caret, and what that really is the xth root. So you're telling it to take the third root if you look above that button. And then you're going to type in 27,000, and then you're going to type in equals. So practice that. Type that in. If your calculator, if you typed it in the right way, you should get radius equals 30. So that is the radius of the boulder. Now, if you have a graphing calculator, so let's say you have a TI 84 or 84 plus or 83, what you're going to do is you're going to go to Math, and then it's probably the fourth thing down. You see something that looks like this. It is, if you arrow down to that, that means you're going to take a cubed root. And then you're just going to hit that, get down there, hit enter, and then hit 27,000 or type that in, and then hit equals or enter again, and you should get 30 as well. So if the radius is 30, the diameter is 60. And then don't forget your label. It was inches cubed, so we're going to have inches. So the diameter would be 60 inches. You might want to practice that again. Practice taking like the cubed root of 216. So go ahead, see if you can type that in. Try to take the cubed root of 216. And if it's correct, you got a 6. Try to take the cubed root of 1,000. That means what times itself 3 times would be 1,000. So try to type it in your calculator. Even if you know the answer, try to type it in. You should get 10. The cubed root of 1,000 is 10. Next, will you try Unit 9, Practice 7? If you need help, let me know. Have a great day.